Hi all, in this video I am going to discuss Kruskal'S algorithm. Kruskal's algorithm is used to find minimum spanning tree for a connected weighted graph. Basically, the two algorithms are used to find minimum spanning tree. One is Kruskal's algorithm and another one is Prim's algorithm. In this session, I am going to explain Kruskal's algorithm. Before that, we want to understand the two terms. The first one is spanning tree and the second one is minimum spanning tree. The first spanning tree. Here I have an example graph G. So we know that a graph can be represented as G equal to V E, where V is the set of vertices. V is the set of vertices. Here V equal to V1, V2, V3, V4 and E is the set of edges. Here E equal to E1, E2, E3, E4. A graph can be represented as set of vertices and set of edges. The next, what is a spanning tree? So from this graph, next I am creating one tree. So we know that trees are connected and circuitless. So here I am creating one tree, V1, V4, edge is E4. So this is a tree because it is a connected and no circuit, right? And this tree contains only the two vertices of this given graph, right? And this is not a spanning tree. The next I am creating another tree from this graph. Then vertices V1, V2, V3, V4, edges E1, E4, E2. And this tree contains all the vertices of this graph. Then we can say that this is a spanning tree. Okay, so a spanning tree is a tree which includes all the vertices of the given graph. So next I am creating another tree from this graph. The vertices V2, V1, V4 and V3, edges E4, E1, E3. And this tree also contains every vertices of this graph. This is also spanning tree. So we can construct the number of spanning tree from the given graph. Okay, then compare this to spanning tree. Here the number of vertices equal to 4. That is same as in the graph. And the number of edges equal to 3. Okay, so from this we can say that a graph G with n vertices, then the spanning tree having n vertices and n minus 1 edges. Okay, so a spanning tree T of a connected graph G is a tree which includes all of the vertices of G. And next, a graph G with n vertices, then the spanning tree having n vertices and n minus 1 edges. So this is all about spanning tree. The next one, minimum spanning tree. So consider this graph. Here, each edge is assigned a number. Here 1, 2, 2, 3, right? This is known as weight or cost. And this graph is known as weighted graph. That is, a weighted graph is a graph in which each edge is labeled by numbers called weights or cost. Okay. The next, I want to know what are the possible spanning tree from this graph. So I draw few spanning tree. So let us draw one spanning tree. The first I am draw the vertices 1, 2, 3, 4. Then how many edges I should take? 3, right? So I am selecting this edge from this graph and this one and this. Okay, then its weight is 1 and this weight is 2 and this weight is 2, right? Then what is the cost of this spanning tree? Cost equal to 1 plus 2 plus 2, which is equal to 5. The next I will take another spanning tree from this graph, that is 1, 2, 4, 3, the weight 1, 3, 2. Okay, then cost is 3 plus 1 plus 2, which is equal to 6. Okay, and the next I will take one more spanning tree from this graph, that is, this is another spanning tree. Vertices 1, 2, 3, 4, and weight here 3, 2, 2. And cost of the spanning tree, cost equal to 3 plus 2 plus 2, which is equal to 7. So from this example, the some observation, we can understand something. That is, if you have a weighted graph, you may have different spanning tree, right? And the cost of these spanning trees are varying. That is, the spanning tree have different cost, right? And the problem is, can I find out the minimum cost spanning tree from the given graph? Then what is minimum cost spanning tree? So the minimum cost spanning tree is a spanning tree which has a minimum total cost. Okay, so the answer is yes. We can find the minimum cost spanning tree from the given graph. Then how? The first, try out all spanning tree from the graph. Okay, then from that calculate the cost and pick up one that having minimum cost. This is a one method. That is, first try out all possible spanning tree from the given graph, then calculate the cost and pick up one that have minimum cost. But trying all the possible spanning tree is too lengthy process. And is there any algorithm for finding minimum spanning tree? Yes, those algorithms are Kruskal'S and Prim's. Okay, so we can find the minimum spanning tree without trying all the possible spanning tree from the given graph using this algorithm. So in this session, we are focusing on Kruskal's algorithm. The Kruskal's algorithm is used to find the minimum cost spanning tree from the given graph. So let us consider this example. With the help of this example, I will explain you how to find the minimum spanning tree using Kruskal's algorithm. Okay, so the first step, you will arrange all edges according to the weight. First, you will arrange all the edges according to the weight and in which order? Increasing order of the edge weight. That is the first. Arrange all the edges in increasing order of the weight. Okay, and in this graph, which edge have minimum weight? BD and DT, right? So first write BD and DT and its weighs 2, 2. Okay, see, we can write BD or DT first, doesn't matter. The next minimum weightage is CD and AC, right? So right here CD weight 3 and AC weight 3. And the next minimum weightage is CP, right? So CP and the weight 4. The next minimum weight BT, right? So right here BT and its weight is 5 or cost is 5. Then the next one AB, right? So right here AB weight 6. The next minimum edge is SA weight is 7. The next one and the last one is SC weight 8. So this is a first step. Arrange all the edges in increasing order of the weight. The second step, choose the smallest choose the smallest edge from this list and add it to spanning tree. Okay, so this is your spanning tree. And here the first choose BD, right? It is the smallest edge. Then select BD and add it to the spanning tree. Here B, D, its weight is 2. And the next smallest edge is DT. So right here DT. And the next smallest edge is CD, right? Choose this edge and add it to the spanning tree and its weight is 3. The next one AC. AC. Okay. The next smallest edge is CB. Then suppose I'm adding the CB here. Okay, it will create a circuit, right? So we know that this is a spanning tree. It does not contain any cycle. So discard this edge. That is, it is not added here. So discard this edge C. So I'm just erasing this edge. And the next edge is BT, right? So I'm adding BT here. It's also create a circuit, right? So discard this edge also. The next select AB. So AB also create a circuit, right? And discard this edge also. The next one SA. Next smallest edge is SA. So then I am adding SA here. It does not create any circuit, right? And its weight is 7. Then the last edge is SC. So SC also create circuit, right? Here we add the SC. It also create the circuit. So discard this edge also. And finally, this is a minimum spanning tree. So this is the minimum cost spanning tree. Okay, and the cost is 7 plus 3 plus 3 plus 2 plus 2 equal to 17. Okay, so this is the Kruskal'S algorithm. So what are the steps? First, arrange all the edges in the graph in increasing order of the weight. Then second step, choose smallest edge and add it to spanning tree. So if you adding edges to the spanning tree, first check if it form a cycle. If cycle or circuit. If circuit is formed, discard that edge. Otherwise, add it to the spanning tree. Then this process is repeated until all the edges are chosen or n minus 1 edges in that spanning tree. So here the number of vertices equal to 6 and number of edges equal to 5, right? And this is the algorithm we already discussed. And the first step, sort all the edges in increasing order of the weight. And the second step, pick the smallest edge. Check if it's form a cycle with this spanning tree. If cycle is not formed, include this edge, else discard it. Okay. And step 3, repeat step 2 until there are n minus 1 edges in the spanning tree. So this is all about Kruskal'S algorithm. I hope all got clear idea about Kruskal'S algorithm. Thank you.